And the little subheading under this division is this. Let's try to keep this straight here. With and without remainders. A little subheading here. With / without remainders.
And what with like Mrs. Stone does? W line.
Frankie, come here. I can't continue this way. Is this spell irrelevant?
What is that?
Insignificant. You know what insignificant means? Significant. Since it distracts from the process. You got it. And hinders fundamental. We've already used learning, fundamental educational principles. Now, that's not principle like Ms. Lopez, that's principle as an analogy. I don't know what you'll figure it out. Writing with or without remainders, children. And I don't remember, have we done remainders yet? I don't know. Yes?
No.
Okay, well here's the deal. Let's do this division problem. We've done division problems before. Let's say you've got 40 divided by 6. Okay, that's that whole algorithm with division we already know, right? It's divide, multiply, subtract, bring down. You follow that same pattern. 6 goes into 40 about how many times? Well, that's 6 times. You get 36, which is multiplying. You subtract. We've done this, right? And then when you end up at the end here, okay, I end up at the end here. I don't have any more digits or no numbers to bring down here. This poor little 4 is sitting out over here kind of all by himself with nothing left to go by him or nothing left to do. We call this a remainder. And generally speaking in math, what you do is you just put the little letter R up here and a 4 up there. It just means remainder 4. Okay, and that's all well and good if that is just the problem that you're doing. Another example might be, 17 divided by 5. 5 goes into 17 3 whole times. You get 15, you subtract, you get a 2. Now, when you get your remainder, you always must check to make sure that one thing is true. Your remainder must, I repeat, it must be smaller than this little guy we call the divisor. Because if you get a number that's bigger than the divisor, your number up here is wrong because that divisor would go into that another time. As long as this is smaller than your divisor, it's a good remainder. And with that being said, children, okay, let's say I have, well, it doesn't matter. In the real world, if I ask Nathan to give me 3 remainder 2 cookies, Nathan, what are you going to give me? Exactly. He proves a valid point. In the real world, ladies and gentlemen, there's no such thing as a remainder that you can really work with. It doesn't mean anything to somebody. Jacob, if I said give me a remainder $16, that's not the same thing as $16. It's a remainder of 16. It doesn't have any real meaning to us. So here's what you have to remember. Sometimes remainders are okay. Remainders are okay when we do problems like this, but usually when it comes to story problems, a lot of times remainders are no good. And I'll give you an example of that. Here is a for example, straight out of the book. 16 people are waiting for a boat to cross the river. 16 people are waiting for a boat to cross the river. 5 people can fit on a boat. How many boats do we need? How many boats are needed? Well, most of us know that this is a division problem. You're trying to see how many groups of 5 you can get out of 16. Here's the deal. When you do the division in that, you get 3, which is 15. You subtract, you get a remainder of 1. Okay? Which would mean if I asked Andrew to go get me 3 remainder 1 boats, that makes no sense. And the deal with this is, even if you have, what means is, here's your 16 people. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay? 5 people, these 5 people jump on 1 boat. They're good. Here's my little boat. Doesn't seem to be working real well here. These 5 people jump on the second boat. For some reason the second boat doesn't work very well either. These 5 people jump on the third boat. That's my 3 boats. Well, unfortunately, you just can't leave Mr. One Guy out there to fend for himself because he'll probably die of starvation or whatever. You need a whole nother boat, even if it's just for 1 guy, to take him over. So the answer to this is you need 4 boats. You don't just leave 1 man behind, and there's no such thing as a remainder of a boat. Okay, so you have to decide if it is a story problem. Sometimes you won't use a remainder because it doesn't make sense. You just have to add another thing. Another example might be this. Wait, I'm going to find a good one here. Where is it? Where is it? Sure. 50 trading cards. 50, unfortunately, the Cubs won't make many of those trading cards. 50 trading cards are to be put in a scrapbook. In a scrapbook. Each page holds 8 cards. Each page holds 8 cards. How many pages are needed? How many pages are needed? Give you a chance to write that down and then we'll talk about it. And right away, as you read that problem there, you should say, is there such a thing as a remainder of a page? Can you use a remainder of a page? I guess you could use a fraction of a page, but generally in books you don't rip pages apart, you just put pieces of them in there. So right off the bat, when you do this problem again, please don't just write down an answer. We know it's a division problem, so you are going to take 50, correct, and divide it by 8. How many times does 8 go into 50, Andrew? 8 goes into 50, we'll get the answer. You got 6 times. That gives me 48. I subtract and I have 2 cards left over that are not on a page. Can I have a remainder 2 of a page? I can't. So Andrew, how many pages will I need?
60. Wait, no. 55. Wait. 2. What?
I have 50 cards. 8 of them go on a page. So I divided 8 into 50. I got 6. Remainder 2, but I can't have a remainder of 2.
So you need 10.
On 6 pages, take a look here. I'm putting 8 cards on each of these pages. So that's 48 of them.
7.
Thank you very much. Yes. I need 7 pages because there's no such thing as a remainder 2 of a page. So again, if the problem just looks like this, you can leave it as remainders. If it's You know, if it's 34 divided by 9, it's not a story problem. By all means, take 9 divided into 34. How many times does 9 go into 34, Maggie? Ignore multiplication tables. 9 times 2, 9 times 3. 9 times 4 is 36, which would be too big. 2 is 18, which is too small.
3.
Yes, let's go for a 3. 3 times 9 is 27. I subtract, I get 7. Can I have 7 left over there? Is 7 smaller than the 9?
Yep.
Yes, so it's going to be 3 remainder 7. As long as your remainder is smaller than the divisor, you're okay. If it's bigger, then you're going to have to. Any questions or problems with that? All it takes is a little bit of thinking and common sense. Things you can and can't have